Good evening, students. This is Deekam Pathak from Free Birch Experiences. I welcome you again to this wonderful series called Fun with NCERT. So today's session will be taken by Ms. Nubu Chaudhary, and without any further ado, let's get started. Ms. Nubu, please continue on with the session. Thank you.
Okay, thank you, Deekam. So dear students, welcome to another session of Fun with NCERT. So in today's session, we will be talking about reflection and refraction of light. Okay, so we will be doing some very basic things related to this particular topic. And of course, it's a very, very important topic from your examination as well as from your daily life point of view as well. Okay, if Deekam, would you confirm that you can hear me properly? Okay, okay, thank you so much. So before we actually go ahead with reflection and refraction of light, we would like to discuss a few properties which are which light has. Okay, so we'll talk about light as well, but first of all, let us talk about certain properties which we see in our day-to-day lives. So if you see in the first picture, okay, this is number one. So in the first picture, this is a picture of a rainbow. Okay, so we all know that when does rainbow occur? Mostly during the rains. So we are able to see rainbow. Okay, now what is the main fundamental concept behind this rainbow? We all of us know that we get light from the sun, right? And the light which is coming from the sun is not simply pure white light. Okay, it is a combination of several other colors. Okay, the form in which we see white light is basically composed of several colors. We have already heard about this term, I think, which is Vibgyor, Vibgyor. So these are the fundamental colors which are actually building up the white light of a rainbow. So V is violet, I is indigo, B is blue, G is green, Y is yellow, then orange, and finally red. So all these 7 colors basically constitute your rainbows. Okay. The next picture, if you see here, is the combination of colors. Now, talking about light, light can be represented in different combinations and different patterns in which the human eye perceives. Just look around the world, okay? Look at the world which is around you. So you will see different types of objects which has different types of colors, right? For example, your table is brown in color, the piece of cloth appears red in color. Okay, the maybe let's say a particular ball is there which is blue in color. Now all these objects are basically reflecting different combination of colors or different colors. Okay, so this is another property of light. So first we talked about the first property, which is that the pure white light which we get from sun is not just white light, it is a combination of several different colors. Okay, and the second one is basically that the colors could be represented in different combinations. This third image is representing a leaf. All of us know that this particular leaf or the leaves around us, the green leaves, okay, they are green in color. Why it is just green in color? Why it is not red in color or yellow in color or let's say blue in color? Okay, so these things we will be knowing about. In today's session, that why things appear the way it is. Why do you look the way you look now? Okay, why you have different colors in your body, different colors in different objects, and different colors in different things which are around you. Okay, so all these properties we will be discussing in detail. Moving on to the next slide. So if we talk about light, the first thing is that we have to understand the electromagnetic spectrum. So here, if you look into this particular spectrum, so this spectrum holds a number of number of frequencies, okay, which are actually existing in the form of waves. Okay, so radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. So all these rays are there, but they are not actually visible to our naked eye. Okay, so these waves are already, these are different frequencies of light which are already there. Okay, but it is not visible to our naked eye. Whatever we can see, it is known as the visible light, and this visible light basically ranges from 400 to 700 nanometers. Okay, only in the range of this particular range, or only in this range, we will be able to see the light. So whatever we see around us basically falls within 400 to 700. Out of that also we cannot see. All right, and X-rays, etc., those can be experimented on, or those can be witnessed, but they have a special setup which needs to be used, and they are not visible to our naked eyes. Okay, so we have to understand that if we are um, witnessing an object, or if we see an object which is red in color, so that means that particular object is reflecting waves or wavelength of 700 nanometer. Okay, if we are if we have a ball which is blue in color, that means it is reflecting a wavelength of around 475 nanometers. Okay, so every object which is showing a particular color around us, they are reflecting that spectrum or that particular range of light from their surface. Only then we will be able to see that particular object in the color that it is already in. Okay, suppose the object is emitting light, or the object is reflecting light which is more than 700 nanometers or which is less than 400 nanometers, it will be invisible for us. Okay, we will not be able to see that object at all. So we have to understand that the visible spectrum lies within this particular range, which is 400 to 700 nanometers, and whatever colors we can see around us are basically the colors which are reflected, or basically the wavelengths which are reflected from the surfaces of those objects. Okay, now if we look into it in a better way, so how do we see the color of light? That means we already talked about in our first slide that the white light that we see is basically composed of 7 different colors. Okay, 7 different colors, vibjor to be very precise. Okay, so these 7 different colors are there. Now how do we identify the different colors, or how does our human eye identify the different colors? Now, as already mentioned in my previous slide, okay, so this, all the 7 different colors, first of all, fall into a particular surface. All right, fall into the surface of an object, and the color which is actually reflected by the surface is the color that we see that object to be in. Okay, now let us consider a ball, and all these different colors, okay, they will be incident on this ball of light. I mean, all different colors of light. So it will be incident in this ball, and if it is reflecting the blue color, so let's say it is reflecting the blue color and absorbing the other colors, that means this ball will appear to be blue in color. Similarly, if it is reflecting the red color, okay, the surface will appear red in color. So this is a very, very fundamental concept which is related to light. Okay, so we see different objects in different colors because they reflect that color and absorbs the other colors which belongs to the spectrum of light. Okay, now we talked about the 7 different colors. Okay, so we can see different colors and different combination of those colors. Now, what about the white objects? Suppose I have a piece of paper and it appears white in color, right? Now, what about this white object and why does it appear so? So, in order to understand this, we have to understand that in white objects or the objects which are white in color, they reflect all the 7 colors. Okay, all 7 of them would be reflected from the surface. That means all of the colors, whenever we see them together, it gives us the white color. Okay, so the object will appear to be white when all 7 colors will be reflected from the surface. Then simultaneously, if we talk about the black object, now many objects around us are black in color. Okay, so why do we think that this black object appears to be black in color? Okay, this happens so because from a black object, no colors would be reflected. Okay, and all the colors will simply be absorbed in this surface. That is why we say that we in summers, if we wear black clothes, we tend to feel more warm or more the temperature we tend to feel it as more hot because all the wavelengths of light are absorbed by this black color, and since it has energy, so that particular energy is converted into heat energy and the temperature rises up. Okay, so it does not get reflected at all and all the colors will be absorbed within that particular surface. Okay, so I believe this is clear. So next we have to talk about what is light. Okay, so now if we talk about light, light originates from the acceleration of electrons. Okay, so whenever these electrons are moving, that means light will be generated, and basically light is a electromagnetic wave. Okay, so we will talk about this, but since the primary objective of today's session is to know about the properties of light and the reflection and refraction concepts, so we will not be focusing much on this as of now. Just remember that we have to uh, that light is an electromagnetic wave and it is produced from the acceleration of electrons. We can consider two different natures of light. One is the particle nature and the other is the wave nature. So what is this particle nature comprising of? Suppose I have a torch. Okay, I'll show it to you. Let me first stop this. Okay, so now if I have a torch, okay, I have a torch, and from this torch I just switched it on. Okay, and I'm trying to focus it into a particular object. So let's say this. Okay, so light from the torch is falling in onto this particular ball. Okay, now what happens is that what is this how does this phenomenon look like? This looks like that I am continuously shooting particles which are present in light into this particular ball, right? It is not creating any wave-like structure. It is not creating any ripples. It is simply what it is doing. It simply feels like that I'm shooting this ball with this particular light. Okay, so this is the particle nature of light, where no other parameters are associated except for that it appears like I'm scattering or shooting the particles of light into a particular object, right? So the next nature of light is the wave-like nature. So why do we call light as light as a wave? Okay, so because just look into this particular glass, and if I'm trying to disturb this glass, let's say this, okay, the glass of water, I have water inside this glass. So now if I'm trying to disturb this particular water, by just poking into the surface, it is creating ripples around the point in which I am poking it. Okay. So this means that whatever I am trying to do, okay, I am creating a wave-like effect. Okay. So this wave-like effect is also correlated to light, where we can create this particular phenomenon, or this particular phenomenon is created in lights as well. Okay, or light as well. So now let me go back to my screen. Sorry. Okay, so when I'm talking about light, we already saw what particle type of nature is what wave nature is. So in particle nature, it will be considered with the particles, and in wave nature, it will try to create a ripple type of an effect, just as the way we do it in your water. Okay, so if I'm poking the surface with something or throwing something into the water, it will create a wave-like phenomenon here. Okay, so this is the wave nature of light. All right, so moving on to the next slide. So talking about light, now we have to understand that light always travels in a straight line. Okay, so I'll write it for you here. Light always travels in a straight line. Okay, in a particular medium. Okay, in a particular medium, we are not considering different medium here, we are considering just one medium. And if we are considering this one medium, then light will always travel in a straight line. In this particular diagram, if you see, I have incorporated three different cardboards here. Okay, three different cardboards here, A, B and C. Now if I'm trying to light a candle, which is a source of light here, okay, and I'm trying to look into it across the three cardboards, okay, by just making a hole into this cardboard, you will be witnessing that the light will be traveling as a straight beam across the hole, and what we could see is just a single line or single ray of light which is coming from this particular candle, and it is straight in nature. So light always travels in a straight line, and this particular phenomenon is known as the rectilinear propagation of light. Okay, that means it will always be traveling in a straight line in a when the medium considered is one, okay, or in the same medium. Now this rectilinear propagation of light creates a very very interesting phenomenon which you have seen every day, which you are witnessing every day, that is the shadow. Okay, so how are these shadows made, or how do we get shadows? Shadows are the result of your light which is traveling in a straight line. Now let me consider a I'll stop this sharing so that we can go ahead with this thing. Okay, can you see me, Deacon? Can you see me? I think it's not there. Okay, hang हो जाए नहीं तो Deacon है कि नहीं है? I think okay, so now if I'm considering a ray of light, okay, in order to show you the concept of shadows. So as I've already mentioned that light travels in a straight line. Now if I'm trying to focus a light, okay, a ray of light into this particular ball. Now because this ball is an opaque object, okay, this ball is an opaque object, That is why it is blocking its way, okay, and blocking the way or blocking the ray of light, and it is creating a shadow below on the table, if you can see. Okay, so on the table it is making a shadow. If I remove this, the shadow will no longer be there, because now the light is moving in a straight line in the same medium without any blockage. You can try this experiment. Okay, so if I have a paper here, all right, I have a paper here, and this has certain holes, as you can see. Okay, so if I'm trying to like yes, if I'm trying to just focus light onto these holes. Now what I'm getting here is, it might not be very visible. If you try this experiment at your house, you will be able to get the result. Okay, you will see that the shadow of the paper is here, but the light is successfully passing through the holes. Okay, passing through the holes, so it is not getting blocked anywhere. All right, so this is a very interesting experiment that you can do with the shadows. So because this is an opaque object, it will block the way of light or ray of light, and it will create a shadow of the object which has blocked. Okay, it will simply create a shadow of the object which has blocked that light. Now had this been a transparent ball, okay, light would have simply passed through it, like in this particular glass. Okay, so if I'm considering this glass of water, so without water, if I'm considering, the light will be passing through it. It is not getting blocked. Okay. It will not be getting blocked. If you can see the light, okay, it is passing through the glass, and below this, I'm not getting a shadow here. I'm getting the ball shaped light, okay, down. So light is passing through this water here, right? However, since I am not using a transparent ball, if I am doing this, light gets blocked and a shadow of the ball is created. Okay, so you can try this experiment at your home to find out how you can create a shadow and how this light actually impacts the shadow. Okay, now moving on to the next important concept. All right. So moving on to the next important concept, um, the propagation of light, or how light travels, they are actually categorized into two different types. One is reflection. The other one is refraction. We also have the third type of propagation, which is known as absorption. So we will be talking about reflection and refraction, and absorption I will just brief you out. Okay, so let's move ahead. So reflection of light, so it is the phenomenon of bouncing back of light in the same medium or striking the surface of any object. Okay, so suppose I am throwing something. For instance, let me take that I am simply um, I'm simply hitting the table with this ball. Okay, so this ball bounces back, right? So this phenomenon also happens with light, which says that if the light is bouncing back in the same medium, so I have thrown this ball from the air, and when it bounces, it comes back to the air on striking the surface of any object. So then reflection of light is said to be there, or reflection has occurred. That means I will be incidenting, or I will be throwing light on a surface, and from that surface, if the light bounces back, then it is said that reflection has occurred. Okay, and we also have the next point, which says that path of light rays changes without the change in the medium. Okay, now this particular path of light, now to understand this, I have to draw it and show you. Okay, the path of light rays changes, sorry, Just give me one moment. Deacom, are you there?
Yeah, I'm here. Yeah, actually your screen is not being shared, ma'am.
Okay. Are you there, Deacom?
Yeah, I'm here. Can you hear me?
Yes, I can hear you.
Yeah, your screen is not being shared actually.
There's a power cut here, so.
Oh, acha, acha, acha.
Okay, just give me 1 minute.
Sure, sure, sure. All students are requested to please wait a little bit. Ma'am is suffering a power cut in that place, so please hold on.
Okay, I think you can see my screen now. Okay, so moving ahead, we talked about this particular second point, which says that the path of light rays changes without the change in the medium. That means the light rays, wherever it is coming from, okay, that particular direction is changed without changing the surface or without changing the medium, right? So for this, let us look into this diagram, all right? And if we look into this diagram, we will see that light is coming from this point, okay, from the incident ray, or we can call the light which is falling into a surface as the incident ray. And this path gets changed in the form of reflected ray, okay, which has a different direction and which has a different path, of course, but it causes no change to the medium in which it is traveling whatsoever. Okay, and this incident ray and the reflected ray, all of this happens within this particular surface. Okay, so this is a surface in which the ray of light fell on, and after it got reflected from the surface, it is actually reflecting back to the same medium without changing the medium, but the path is changed. Now, if we talk about the center straight line, which you can see here and is named as normal. So this normal is basically a perpendicular which is drawn to the surface to which the light is incident on. Okay. So this angle of incidence and the angle of reflection is the angle in which the incident ray is incident on the surface along with the normal. That means I'm talking about this angle, the left angle. Okay. So just 1 minute. So if you look into this diagram, this normal would be the perpendicular that I have drawn to the surface, okay, and the incident ray and the normal is basically making an angle with each other, and this angle is known as angle of incidence, and the angle of reflection is the angle between the reflected ray and the normal. Okay, so this is the angle between reflected ray and the normal, and this is the angle between the incident ray and the normal. Okay, so this reflection is basically observed very nicely, or it is observed very clearly in optically plane surfaces or mirrors. Okay, so we talked about the first phenomenon, which is reflection, and optically this reflection happens in a very nice manner, or you can see it in a very good manner in an optically plane surface. Okay. Now, what do we mean by this optically plane surface? The optically plane surfaces are those surfaces which are very, very smooth, okay, and they do not have any rough edges or roughness in between or any ups and downs in between, okay. Now, if you consider a piece of paper, that also might seem to be very plain, but actually when you will look at it into the macro, from the macro level, this is not plain, okay. Mirrors generally are considered as optically plane surfaces, and these are the surfaces from which light gets reflected very, very easily, okay, or it is very, very easy to reflect any light. Now, all of us have mirror in our house, okay, all of us have mirror in our house. In order to look at it, we will see this, okay. So this is a mirror, okay, all of us have a mirror in our houses. Now this is an optically plane surface, okay, and this optically plane surface, if I am putting an object in front of it, so let me put a pencil in front of this particular mirror, okay. So if I'm putting a pencil in front of this, I will see the image of this pencil on the mirror, okay. The particular pencil will be, the image of the pencil will be seen in front of this mirror. Now what happens actually? Light which is being emitted, I'll make an angle so that it is easier for you to see. So light which is basically incident from this particular pencil to this surface is reflected back to the same medium, and we can see this particular image which is formed, okay, image which is formed in this mirror, okay. So this is one of the very common applications of reflection, where the light from an object is incident on a surface, and that surface is reflecting it into back to the same medium, okay. So when this particular surface is reflecting those colors of the object to the same medium, we can see that object, okay. All the objects around us, they definitely reflect some color or the other. Now whatever color is reflected from that object, that means we can see that object in that color, okay. That we have to understand. So we see this pencil in the way it is because this entire object is getting reflected. The light from this object is getting reflected from this surface, and when it is getting reflected from this surface, we can actually see the image of this particular pencil here, okay. Likewise, if we look at the mirror, we see our image being formed because it is reflecting the colors which are, or it is reflecting the light from us, all right. So this is the way in which your common mirrors work. Some of the common things which will exhibit this phenomenon of reflection is a spoon, okay. If you have this spoon is, I mean, all of us have spoons in our homes. So if you look into the back of the spoon, okay, and take it from a closer view, you will see that your photo is getting reflected here, or your image is getting reflected here, okay, on the back side of the spoon. Likewise, if you look into the inside of this spoon, okay, you will see an inverted image. If I am doing this, okay, this will not be very visible. You can try this out at your homes. So if I am doing this pencil will get reflected from, image of this pencil will get reflected from the back side of the spoon. However, if I am using the front side of the spoon, it will show me an inverted image here. Okay, it will show me an inverted image here. So basically this is known as a convex mirror, and this is known as the concave mirror. So here there are different ideas or different logic on your focal length and the point from which it is incident on. So all these things, they explained well in your NCERT books. Okay, so you can go ahead and read them to find out why this thing happens. Okay, why a concave mirror reflects an image which is inverted in nature. Okay, as far as this particular plate is concerned, so this will also act as a mirror. Okay, this will also act as a mirror. Metals are basically considered as the good reflecting agents, or they provide to be good reflectors. You can always see your face in your vessels which are there in your homes, in the metal vessels, right? So they basically serve as a very, what do you call that, very potential mirrors that could be used in order to look into, or in order to groom yourself, right? So this metals, basically they have a lot of free ions which can be reflected from the surfaces, and in that sense it will be used as a very good mirror. Now all these things, again, they are available in your books. You can go ahead and check them out. All right, because today's session we will not be getting much time in order to discuss each and everything. We have a lot of things to cover. So I will just give you a pointer regarding to check out why these things happen, why metals behave mirror, good agent of mirror. Okay, now let us move ahead. We already talked about optically plane surfaces. So there are various surfaces which are not plane. Okay, so before we actually go into refraction of light, I would like to discuss a few things related to these plane surfaces and the types of reflection. So if we are considering types of reflection, there is a regular reflection which is done, or which happens in case of mirrors. Okay, so for this, the regular reflection phenomenon is this. However, there is also a diffuse type of reflection which happens, and this is exclusively for irregular surfaces. Let's say I have a piece of paper, or the curtain, or the bed. Okay, all of them will behave as irregular surfaces, and they will be exhibiting diffuse type of reflection. In regular reflection, I is always equal to R. Okay, now what is this I? I is the angle of reflection and angle of incidence, and R is the angle of reflection. So I will always be equal to R. This is a very ideal concept. However, in diffuse refraction, the same diagram, okay, it is represented as, let's see, I have a normal here, okay, and this surface no longer looks like this. Let me say it is a rough surface. Okay, it is not a plane surface. So whatever the light I am incidenting on this surface, they get reflected in different directions. Okay, they get reflected in different directions. Sorry, it will not cross the normal. They will get reflected in all possible directions. So here the angle of incidence is not equal to the angle of reflection. Okay, this happens exclusively for irregular objects or irregular surfaces. So the mirror that you use in your home, okay, that is a optically plane surface. However, the wall in which the mirror is fitted, it is basically a rough surface or a irregular surface, okay, where diffused reflection would occur. And that is the only reason that even though a piece of paper will reflect light, or a piece, or let's say the wall is also reflecting some light, okay, even after all the objects being reflecting light, you will not be able to get your image in a wall or in a piece of paper, okay, because they are not optically plane surfaces which will reflect the incident ray exactly with the same angle as that of the angle of incidence. Now talking about the refraction of light. So this is another phenomenon which is exhibited by light, and this is basically, this phenomenon happens because of the change in direction of light when it is traveling obliquely from one medium to another medium. In reflection, what we saw was everything was happening on the same medium. That means the angle of incident or the incident ray, the normal, and the reflected ray, all of them were lying on the same surface, right? And if we are considering refraction of light, the incident ray, the normal as well as the refracted ray, they do not lie in the same medium. They basically, at all points of time, there are two mediums that are involved. Okay, two mediums that are involved. And one is known as the rarer medium and the other one is known as the denser medium. What do I mean here by rarer medium and denser medium is that rarer medium has lesser optical density, okay, lesser density, and the denser medium has more density, okay. So both of them has different density within it, and hence the refraction of light will take place between these two mediums. To get a more clear concept of it, we have to look into this diagram. So again, I have two different mediums here. One is air and the other is glass. Now, air essentially we have considered it as the rarer medium and glass is the denser medium. Talking about both these mediums, we have to make sure that both these two mediums do not have the same density, otherwise it will be considered as the same medium. Okay, now this ray, the light at which it falls on the surface of the boundary, okay, these two mediums are separated by this boundary, and the incident ray is falling on this particular boundary. So once it is incident on this boundary, okay, at this particular point, refraction would take place with respect to the normal which is drawn perpendicular to both the mediums, okay, to the boundary of both the mediums. So this is the refracted ray that I am talking about. So this refracted ray is not in the same medium, okay. Refraction always takes place in the other medium which we have used, okay. So it will not be in the same medium, it will be in the other medium and it will be moving away from the normal, okay, with certain angle, and this angle is known as the angle of refraction, okay, refraction, angle of refraction. And this we have already done. This is angle of incidence. So both these two have different mediums. This we have to be very, very clear about. Okay. So like the previous diagram we saw, reflection was all of them, all three of them. That means incident ray, reflected ray and the normal, they were lying on the same surface and the same boundary. However, here they have both the incident ray and the refracted ray, they are not in the same medium. Okay, so this it will be more clear to us when we will be talking about the concept behind the bending of this light. So whenever this incident ray is falling onto this particular boundary, we will find that it is moving away, or it becomes a refracted ray, or it is bending in the next medium. Now, why this bending occurs? Bending basically occurs due to the change in the speed of light. So we all of us know that the speed of light is in air is 3 into 10 to the power 8 meter per second, right? So light in air was traveling at a speed of 3 into 10 to the power 8 medium per second, and whenever it enters the medium which is glass, okay, the speed of light is basically reduced, okay. It will become reduced because this glass has more density than air, okay. And since it has more density than air, what will happen? The angle of incidence will be greater than the angle of refraction. So this we have to remember, that the bending of light is basically the phenomenon behind refraction, and this happens because the speed of light changes in different medium. Let's say when it reaches to the second part, second medium, the speed becomes 2 into 10 to the power 8 meter per second. So under these circumstances, the light will bend away from the normal, okay. The speed in which it was coming, it will now no longer be going in the same speed within a medium. Now again, when it reaches this boundary which is separating the air, let's say it is, again this is air, okay, and the light is traveling from the glass to air, and glass is denser whereas air is rarer. So here again a refraction will take place where it will move further away from the normal, because air is rarer and the light can travel at a much more faster pace than what it was traveling in glass. Okay, so here again another refraction will take place. So we have to understand that this refraction takes place in two different mediums, and every time the ray of light it encounters a denser medium, it will move more towards the normal. Of course, it will move away from the normal first of all, but it will be closer to the normal as compared to the ray of light which is traveling in a rarer medium after refraction. So let us look at a few points. Okay, so speed of light increases and decreases based on density of the medium. So the more dense a medium is, the lesser will be the speed of light in that particular medium. Okay, light travels faster in rarer medium and slower in denser medium. So this we have already talked about. So in glass, the speed of light will be less as compared to the speed of light in air. Okay, in less dense medium, light deviates towards the normal and then in rarer medium. So this should be then. Okay, and so if we have already discussed this point. Okay, so if we have two mediums, suppose this is the rarer medium and this is the denser medium. Now this is the normal that we have, and this is the ray of light which is incident at this particular point. Okay, so if it is a denser medium, it will be refracted, but it will be closer to the normal as compared to, suppose I have another medium here which is rarer medium. Okay, and if my light is incident here again there will be a normal. Here the ray of light will be refracted at a bigger angle. Okay, so if I'm considering P and Q, so P will always be lesser than Q with respect to the normal, because P was in denser medium and Q was in rarer medium. Okay, and both of them are the angle of refractions, right? So this I believe is clear. The last point that we have to discuss is there is no bending of light if the angle of incidence is 0. That is, the angle of refraction will also be 0. Now suppose this is the boundary, okay, and this would be the normal. Now if my light is falling on this direction, okay, that means there is the angle of incidence with the normal is basically 0. Okay, then the refraction of the light will take place, no doubt, but the angle of refraction would also be 0. So you will not observe any such phenomenon. All right. So talking about this, let us see a few examples, okay, based on refraction, a few activity. So now, if I am considering this particular glass, okay, glass of water, and I am placing, let's say I am placing a pencil here, okay, straight. I am placing a pencil here straight. So what do I see? There is no change here, right? Now, if I am creating an angle of incidence, okay, of this particular pencil with the surface of the glass, so what do we observe here? It seems that the pencil is broken, right? It seems that the pencil is broken. A more closer view would be also showing the same thing. I am creating an incident or creating an angle of the pencil with this particular surface, Okay, so what I can see here is nothing but the application of refraction. Okay, I am seeing a broken pencil here because light from this particular object is getting refracted, and we can see the refracted object or refracted light from this particular object as a broken pencil. Okay, however, this pencil is not broken, but the same pencil, if you are, if the angle of incidence is 0, you will see the pencil is not broken, right? It will be acting like a normal pencil. On the other hand, if I'm creating an angle of incidence, this looks like a broken pencil. Okay, so this is a very interesting concept of refraction that you can see. Another refraction example or activity that you can do using refraction is basically you will need a piece of paper, okay, on which I have drawn this arrow. Now this arrow is pointing from the left to the right, okay, from the left to the right. Now when I'm placing this arrow across this glass of water, okay, at a certain distance, what I will see is, I will see that the arrow, just one second, I will see that this particular arrow is now no longer pointing to the direction which it was already in. Instead, it is pointing to the left. Can you see this? The arrow is now pointing to the left. Deacon, would you confirm? Deacon, could you confirm? Yes. Can you confirm if you can see the arrow? Here. This arrow, can you see? Okay, just one second. Just one second. Okay, can you see now? Yeah. So this is the arrow that I'm. No, I just shared it now. I just shared it now. Maybe we missed the previous example where I was showing the pencil. Did you see the pencil experiment? No, not in front of the mirror with this glass. So I think I have to repeat that activity. Okay, I'll do it. Oh, no, no. Okay, no problem. I can do it now again.
Yeah.
So now I think we have to repeat that experiment. So as already mentioned, in refraction, what happens is, this is a glass of water which I have. Okay, as already mentioned in my slide. Now, if the angle of incidence is 0, okay, so the angle of incidence is 0. That means I am pointing the pencil straight to this particular glass. Now at this point, what I can see is, it is a normal pencil which is straight and it is inside the glass. Now if I am bending it a little to create an angle of incidence here, okay, so if I'm creating an angle of incidence, okay, this pencil will now get, the light from this pencil will get refracted, and what we can see here is a broken pencil. Okay, it looks like the pencil is broken. Okay, it does not look like a single pencil. From this point to this point, it looks like another pencil, another part, and the next part is from this point to this point, right? So I can see two different parts of this pencil if I'm creating an angle of incidence here. All right, so this is a typical phenomenon of refraction. Similarly, the last point, as I mentioned, if I'm not creating any angle of incidence, that means light is simply falling perpendicular to the boundary or perpendicular to the normal, parallel to the normal, or there is no such angle of incidence, then there will be no refraction. And if there is an angle of incidence, definitely there will be a refraction. This is happening because this is the air, this is water. So there are two different mediums, right? And the light is traveling from a rarer medium to a denser medium. Hence, the refraction is taking place. And what you can see here is a broken pencil. Okay, so this is one of the very interesting experiments which you can show to your friends and your family members that how basically refraction works. So I'll just skip it here. Now, talking about the next experiment or next activity for refraction. So that is, so I have a piece of paper where I have drawn an arrow. Okay, I think you can see this arrow now. Decom? Okay, so this arrow is pointing from left to right, right? This pointing arrow is pointing from left to right. I have drawn this in this direction. Now what happens is, if I am trying to look into this arrow from within a glass, what I'll say is the arrow, it is getting reversed. The direction, it is reversed, right? It is now pointing from right to left. Okay, so why this is happening? Because again, this particular arrow is emitting light, okay, which is traveling from air to water, and we are checking things from behind the glass, okay, and through the glass. So we are involving two different mediums, and since this arrow is reflecting light which is getting refracted into medium, that is why the direction of this arrow gets changed. Okay, so this is another interesting phenomenon which you can observe. All right, you can observe this. In reflection, everything will happen in the same medium. However, in refraction, there has to be two mediums involved. Otherwise, refraction will not take place. Okay, like I showed you, if you have a ball, okay, and you are throwing some light into it, okay, you are throwing some light into it, what you are getting here is basically a shadow, right? Now, light is getting blocked with this particular ball, and that is why this shadow is created. Now again, if I'm passing this light through this glass of water, okay, that means it is a transparent medium or transparent glass. So now light is directly passing through the glass, and we can see the glass, see the light being focused there on the table, right? So it is not creating any shadow, it is simply getting passed. So we are using a transparent medium here, right? And here we are using an opaque medium. And whenever we are using an opaque medium, there will be a shadow against a light. Similarly, in reflection and refraction also, this medium plays a very, very important role. That is, if it is in the same medium, reflection will happen. And if it is in a different medium, then refraction will happen. Okay, so these are the very fundamental information which I have shared with you today through different activities. Okay, now your job would be to go back to your books and learn more about it. There are a lot of interesting experiments as shown in this particular spoon. Okay, you try looking into this spoon and you will see that you will get a normal image when you are looking at the back side, and you will get an inverted image when you will look into the inside of the spoon. So this has a very interesting concept, because mirrors again can be classified into concave mirrors and convex mirrors. Generally, convex mirrors will give you the normal images or normal object, okay, the image of the object, whereas your concave mirror will give you the reverse image. Okay, so all these experiments you can try out, and all of these are mentioned in your textbooks. All right, and coming back to the same question which we put in the first slide itself, that why leaves are green in color? Because okay, other wavelengths are absorbed by it, and only the green color is reflected, and that is why we can see the different colors of different objects which are around us.
Ma'am, sorry for interrupting.
So
sorry
that is all. Yes.
Hello, but I think when you mentioned, when you're explaining why leaves are green in color, I think there was some internet disturbance. I think the answer got a bit cut off. Could you please explain that again, like why leaves are green in color from that point?
Okay. No, this was the very first slide, so I'll share once. I'll share once again.
Sure. Like there was an internet disturbance, so it was like it got a bit cut.
Okay, no problem. No problem, Deku. So basically we see colors the way it is because of this phenomenon. Okay, so we talked about that the rainbow is made, the white light is made up of seven different colors, right? Vibgyor, violet, indigo, blue, green, yellow, orange and red. So whenever, suppose I have a leaf, okay, let's say this is a leaf, and whenever light is incident on this particular leaf, this leaf will absorb the chlorophyll which is present, chlorophyll pigment which is present in the leaf. They will be absorbing the other wavelengths of light, and it will be reflecting the green color from the leaf. And that is why you will be observing the green color in the leaves. Okay, so I believe this is now a little bit clear. And as far as white objects are concerned, all the colors of the Vibgyor would be reflected, or of the visible spectrum would be reflected. In case of black object, all the colors would be absorbed by this surface. Okay, so this is how things work. This is how you see different objects. Okay, or this is how you see, perceive and understand different colors that are around you. Okay, so this is all about refraction and reflection, and this is just in a nutshell. So we will be talking more about it maybe when we have further sessions related to it. Otherwise, also you can go to your respective books and you can understand the concepts really well. They have a lot of activities also. Today also we did around 5-6 activities showing you how things work. Okay. Now it is entirely your job to go and explore further. All right. So this is all from my end for today and on the chapter based on reflection and refraction. Okay. So we can call it a day. And over to you, Dekom. If you have any questions, you can directly post it in the group.
Thank you so much, ma'am. Thank you so much for this session. And so this marks the end of this session. And thank you so much, students, for joining us. And thank you so much, Ms. Nufu, for giving your time for this session. And yeah, until next time, thank you so much. Good night. Bye-bye. Take care.
Okay. Bye. Thank you, Dekom.
Sure.
We'll see you again.
Sure.